Alright, so in this video we are going to review stoichiometry. So we have been working on just basic mole calculations, and really what we've been doing is we've been converting one unit of one thing to another unit of the same thing. With stoichiometry, we're going to convert one unit of something to a unit of something else. So it's always about going between different substances. So we use a mole ratio if we're going from substance A to substance B. So if the problem says something about, gives you information about substance A, but then it's asking about more information about substance B, you will have to do some sort of molar conversion using the mole ratio. Okay, so the mole ratio is going to be found with the coefficients of your balanced equation. So right here, our mole ratio for hydrogen to oxygen is a 2-to-1 ratio. Our mole ratio between hydrogen and water would be 2-to-2 or 1-to-1, and so on. So we can make a mole ratio between any of the reactants and products, and any of the reactants and reactants, or products and products. So if your question is saying something about substance A, and then it wants information about substance B, you're going to have to go through the mole. You need a balanced chemical equation in order to do that problem. So your conversion factor for going between moles of substances will be the coefficients. So many moles of A is equal to so many moles of B, and these numbers will come out of your chemical equation. Alright, so how many moles of oxygen will react with 16.8 moles of sodium? So again, we're given information about one item of something, so sodium, and then I'm asking about the oxygen. So I'm starting with 16.8 moles of sodium. So if I want to go from moles of one thing to moles of another thing, that's just one step. So moles of sodium will be on the bottom, and moles of oxygen will be at the top. So that would be 1 mole of oxygen for every 2 moles of sodium. So 16.8 divided by 2 should give me 8.4 moles. All right, well, let's look at something a little bit more complicated. So at STP, how many molecules of oxygen react with 632 decimeters cubed of butane? Well, remember, a decimeter cubed is really the same thing as a liter, so we have 632 liters of butane, and we're trying to get molecules of oxygen. So we have to go through the mole. So we're starting with liters, and I want to go to molecules of oxygen ultimately, and this is of the butane. Well, if I want to get from butane to oxygen, I have to go through the mole. So I know that there are 22.4 liters for every 1 mole of a gas at STP. So I'm going to use that information to go to moles of what I have. Then at this point I can go to moles of what I want, which is oxygen. I'm going to use the mole ratio to do that. And then I can go to molecules. So I have 632 decimeters cubed, or liters, of my butane. And then I want to go to moles of butane. And remember, you can only use this number if it's a gas and at STP. So 1 mole is equal to 22.4 liters. Okay, so now we can go to moles of O2, that goes on top, and moles of butane on the bottom. So now I have moles on top of moles. I'm going to look at my balanced chemical equation. So there are 13 moles of O2 for every 2 moles of butane that I combust. So now I can go to molecules. So molecules on top, moles on the bottom. 1 mole is equal to so many molecules. That's equal to 6.02 times 10 to the 23rd. So then, when I do the math, multiply your top numbers, multiply your bottom numbers, and then divide. I should get 1.1 times 10 to the 26 molecules. All right, so let's look at another example. All right, so how many grams of potassium will react with 465 grams of nickel 2 phosphide? So the nickel 2 phosphide is this. I have grams of this, and I'm going to grams of potassium. So again, I have to go through the mole. Anytime you want to go from one substance to a different substance, you have to go through the mole. So I'm starting with grams of nickel phosphide, and I want to go to grams of K. So in order to do this, I'm going to go to moles of what I have. And then I can go to moles of what I want, which is just of potassium, and then I can go to grams. And anytime I'm going between grams and moles, I'm going to use the molar mass. So I'm starting with 465 grams of nickel phosphide. Let's go to moles. So 1 mole of nickel phosphide is 238.74. I get that from the molar mass. It's through the mass of 3 nickel atoms and 2 phosphorus atoms. So now I'm going to go to moles of potassium. So moles on top of moles, I'm going to look at my equation. So there's 6 moles of potassium for every 1 mole of my nickel phosphide. So now I can go to grams of potassium. So 1 mole is equal to 39.09. And now you can go ahead and do your math. Take all the top numbers, multiply those, take all the bottom numbers, multiply those, and then divide at the end. We will get 456.8. And if we were rounding, that would be 457. All right, so if I have 2.5 molar solution of nickel phosphide and it reacts with 20 cubic centimeters, so I take 20 milliliters of that solution and I react it to potassium, how much nickel will be produced? Okay, so we have a little bit more information here. We have a molarity, and then we also have the volume of the nickel phosphide. So we are looking at nickel phosphide solution, and then we want to know how much nickel is produced, and more specifically, the number of grams. That should be written in there. That's a typo on my part. So we have 2 numbers. We are not going to start with a molarity because the molarity is really a conversion factor between moles and liters of that solution. So we always start with the volume. We don't start our stoichiometry problems with a molarity because that is a conversion factor between moles and liters. So I'm going to start off with 20 cubic centimeters, which is the same thing as a milliliter. So a cubic centimeter is the same thing as a milliliter. A cubic decimeter is the same thing as a liter. So I have 20 milliliters. So if I want to go from milliliters of my nickel phosphide, and I want to go to grams of nickel by itself, so the nickel that's here, I need to go through the mole. So before I can even get to the mole here, this has to be in liters. So I'm going to go to liters of my solution. Then I can go to moles of what I have. And then I can go to moles of what I want. And then I can go to grams of what I want. So I have 20 milliliters to start off with. Convert to liters. So for every 1 liter, I have 1,000 milliliters. And then I can go to moles. So I'm just following the map here. So now, moles. There are 2.5 moles of nickel phosphide for every 1 liter. So I'm using my molarity here. And then I can go to moles of what I want, which is nickel by itself. So moles on top of moles, I'm going to use the coefficients. So that's 3 moles of this of nickel for every 1 mole of nickel phosphide. And then the grams of nickel. Well, 1 mole is equal to, let's see, 58.7. That comes off the periodic table. Now, just go ahead, do your math. Multiply the top numbers, multiply the bottom, and then divide. We will get 8.805 grams at the end. Technically, just 8.81 if we were rounding. All right.